A wall of stone stands cold and silent, then dawn reaches it, and in a single breath the wall catches fire. Blue floods the floor like deep water. Red burns across pillars like spilled embers. Gold trembles over dust, over smoke, over bowed heads, over rough hands. A building that should feel heavy suddenly feels weightless, as if light itself has been trapped, cut, and taught to speak. But here is the real mystery. How did medieval craftsmen make stained glass powerful enough to survive for centuries, brilliant enough to transform a cathedral, and precise enough to tell entire stories, without electric furnaces, steel cutters, chemical factories, or modern measuring tools? The answer is stranger than most people imagine, because a stained glass window did not begin in a church. It began in a forest, in a furnace, in ash, in sand, in metal, in smoke, and in the hands of artisans who understood that light could be built like masonry. In the great age of European stained glass, especially between the 12th and the 15th centuries, workshops across places like France, Germany, and England turned colored glass into one of the defining arts of medieval civilization. Much of what we know about how they did it comes from a 12th century text by a monk known as Theophilus, alongside surviving medieval windows and technical analysis of them. At Chartres Cathedral, one of the most famous surviving ensembles, much of the stained glass dates from the early 13th century, and it still gives us one of the clearest windows into the craft at its height. So let us step into northern France, in the age when Gothic cathedrals were rising and stone walls were opening to light. Imagine a master glazier attached to a cathedral workshop. He is not just a decorator. He is part engineer, part chemist, part draftsman, part storyteller, and part merchant. Because the making of a window begins long before a single piece of colored glass touches the lead. And if you enjoy seeing how entire worlds were built by hand, subscribe now, because this channel is about the labor, the intelligence, and the hidden systems behind the objects people now take for granted. The first surprise is that the cathedral workshop often did not make the raw sheet glass itself. Medieval stained glass painters and glaziers commonly bought blown sheets from merchants who dealt with glass houses directly. That means the process was already divided between specialists: the men who made glass in intense, fuel-hungry furnaces, and the men who turned those sheets into narrative windows. Even in the Middle Ages, this was not a lone genius at work. It was a supply chain. So where did the material come from? At its simplest, medieval glass depended on sand and ash. The sand supplied silica, the skeletal body of the glass. The ash, often woodland ash, supplied the alkali that helped the mixture melt. In Northern Europe, after about the turn of the first millennium, glassmakers largely relied on wood ash, giving rise to the kind of potash-rich glass often associated with medieval forest glass production. This was not chemically pure material from a laboratory. It was local, inconsistent, and alive with impurities. Those impurities mattered. They changed durability. They changed color. They changed the entire character of the finished window. That means a stained glass window began with landscape. Trees had to be cut and burned for ash. Sand had to be gathered. Furnaces had to be fed for long periods. Every shard of blue in a cathedral window carries a hidden cost in woodland, labor, heat, and transport. Before stained glass became a religious image, it was already a triumph of resource extraction. Then came the furnace. Inside the glass house, the raw mixture was heated until it passed from granular matter into a glowing liquid. To color the glass, powdered metals were added, while the glass was molten. Medieval sources and museum scholarship describe colors formed through both the natural chemistry of the ash and the deliberate use of metal additives. Cobalt could drive strong blues. Copper could help produce reds, blues, or greens depending on conditions. Iron and manganese, whether present as impurities or manipulated through firing conditions, could shape a broad range of tones. In other words, color was not simply painted onto medieval stained glass. In its most fundamental form, color was born inside the melt itself. This is the second surprise. The most luminous parts of a medieval window were often not surface decoration at all. They were colored all the way through. The glass was not pretending to be blue. It was blue in its body, in its thickness, in the way it caught light and held it. And this helps explain why medieval stained glass feels different from ordinary painted imagery. It is not an image sitting on a surface. It is light passing through matter that has been chemically transformed. Once the molten glass was ready, it had to become a sheet. Medieval glassmakers used two main methods for this. In one, the gather of molten glass was blown into an elongated cylinder. That cylinder was then cut along its length, reheated, and flattened into a sheet. In the other, the bubble of glass was transferred to a pontoon and spun into a round disc, known as a crown, thicker in the center and thinner toward the edge. Both methods required extraordinary speed, timing, and judgment. The glass had to be soft enough to move, but not so soft that it collapsed. Picture that moment. No thermostatic display, no laser reading, no machine giving a perfect repeatable thickness. Only the eye, the hand, and experience earned through burns, failures, and ruined batches. This was a craft of heat memory. A master did not just know what the glass was doing, he knew what it was about to do. When the sheets had cooled and reached the glazier, the work changed from fiery transformation to deliberate design. The medieval window began with a full-scale drawing, often called a cartoon. This was not a casual sketch. It was the operating plan for the entire panel. The design marked the main outlines, the placement of key painted details, and the arrangement of the pieces to be cut. The glazier worked directly from this drawing, using it as guide, template, and assembly surface. At this point, the window already existed in the mind, but it still had to survive translation into brittle, irregular pieces of glass and soft strips of lead. And here we meet the real intelligence of medieval stained glass. The lead lines were not merely a way to hold broken pieces together. They were part of the drawing from the start. They defined robes, borders, circles, architecture, faces, and geometry. The master glazier had to think in structure and image at the same time. Every line had to do two jobs. It had to help the window stand, and it had to help the image read from far below. That is why a medieval stained glass window is closer to architecture than to painting. It is assembled, not simply applied. Now came one of the most delicate stages, cutting the glass. In the medieval period, glaziers did not use the modern glass cutter most people imagine. According to the technical tradition described by Theophilus and echoed by museum scholarship, sheets were cut by applying a heated iron to the surface. The rough shape was then refined with a grozing iron, a tool used to nibble and chip away the edge until it matched the required form. Before diamond cutters became common much later, this was painstaking work. One mistake could shatter the piece, waste precious colored glass, and force the design to be reconsidered. Think about the pressure hidden in that moment. A cathedral wants a face, a hand, a fold of drapery, a circle around a halo, a jewel-like segment in a border. The sheet is irregular. The color may vary across it. The lead lines must remain believable. The piece must fit. And the artisan is doing this with heat, metal, and touch. This is where the craft becomes almost surgical. Dark glass posed another challenge. On lighter glass, the workshop drawing beneath could guide the cutter more easily. On darker pieces, visibility became harder, and glaziers used practical methods to transfer or see the outline against light. The work was deeply manual, deeply physical, and full of small judgments. Modern viewers never notice when they look up at a finished cathedral window. But even after the glass had been cut, the famous image still did not exist. Because colored glass alone could give broad blocks of tone, yet it could not provide eyelashes, folds, fingers, textural shadows, or the intensity of a human gaze. For that, the medieval workshop turned to paint. This is the third surprise. The painting on medieval stained glass was usually not colorful in the way people assume. It was often a dark vitreous paint, ranging from gray-black to brown, used to create trace lines, shadows, and modeling. Museum sources describe this paint as a mixture including iron or copper oxide, ground glass, gum arabic, and a binder such as water, wine, or vinegar. It was then fired so it fused to the surface of the glass. That meant the painter had to think in reverse to ordinary painting. He was not covering a surface to hide it. He was controlling how much light would be allowed through. A dense trace line could define a jaw or a drapery fold. A thin wash could soften a cheek or sink a recess into shadow. Then, with sticks, needles, quills, brushes, or even fingers, the artisan could remove paint to recover highlights and sharpen forms. Medieval stained glass was painted by subtraction as much as by addition. Imagine the workshop table now. Cut pieces lie over the cartoon. Brushes made of animal hair move over blue, ruby, green, amber, and pale glass. One face is given a brow line. One hand is shaded. One robe gains folds. A border receives small repeated ornaments. Everything must remain legible from the nave floor far below in changing daylight through smoke, weather, and distance. Then the painted pieces were fired. This step mattered because the paint was not meant to sit loosely on the surface. It had to adhere to the glass, becoming durable enough to survive handling, assembly, and years of exposure. Firing was the moment of truth. Too little, and the paint could fail. Too much, and the work could distort or be ruined. Again, no modern control panel. Only practiced eyes, habitual timing, and workshop discipline. At this point, a modern viewer might think the hardest part is over. It is not, because now the window had to be built. Each cut and painted piece was laid out according to the design, and its edges were fitted into H-shaped strips of lead called cames. These lead strips were then soldered together where they met. The soft metal created a flexible skeleton strong enough to hold the panel together, while still allowing a complex mosaic of irregular shapes. Afterward, putty was worked into the spaces between glass and lead to help make the panel weather-resistant. Finally, the completed panel was fixed to the supporting iron framework set into the window opening. The image that looked delicate from below was, in reality, a carefully engineered composite of glass, lead, solder, putty, and iron. And this is the fourth surprise. A stained glass window is not fragile art hanging in empty space. It is a structural object. It has to survive gravity, wind, expansion, moisture, and time. The lead lines do not just beautify the image, they distribute stress. The iron support does not just sit behind the work, it makes the image possible. So when you look at a medieval stained glass saint, you are looking at engineering disguised as revelation. If this kind of hidden craftsmanship changes the way you see the past, subscribe here in the middle of the journey. Because the real drama of history is often not in kings and battles, but in furnaces, workshops, and the people who made the world usable and beautiful by hand. Now let us step back and see the full chain clearly. The stained glass window began with raw material gathered from the landscape. Sand and ash were transformed in a furnace into colored molten glass. That glass was blown and opened into sheets. The sheets were traded and brought to urban workshops. A master glazier designed the window at full scale. Individual pieces were cut with heated iron and shaped with a grozing tool. Painters added trace lines and shadow with vitreous paint and fixed it by firing. Then the pieces were assembled into lead cames, soldered, waterproofed, tied into iron armatures, and finally raised into the stone body of a church. That is the complete process. Not a single miracle, a chain of hard-won medieval techniques, each dependent on the one before it, and yet the result still feels like a miracle. Why? Because stained glass solved a problem no mural or tapestry could solve in the same way. It used the weather as part of the artwork. Morning changed it, noon sharpened it, winter weakened it, summer set it glowing, clouds dimmed it, smoke softened it. Sunset made certain colors burn while others receded. The medieval craftsman did not merely make a picture. He made an instrument that played daylight. At Chartres, whose great stained glass ensemble from roughly the early 13th century remains one of the best preserved in Europe, this effect is still overwhelming. The architecture and the glass were conceived together. The stone frames the light. The light completes the stone. That unity is one reason Chartres remains such a powerful witness to the height of Gothic art. And here there is one last revelation. The medieval workshop was not chasing modern realism in the way later painters often would. It was chasing legibility, rhythm, symbolism, and luminous force. That is why the lead lines are bold. That is why faces simplify at distance. That is why color blocks dominate. Medieval stained glass was designed not for a close museum inspection under white lamps, but for a living building filled with shifting light and human movement. Seen that way, these windows were not primitive versions of later painting. They were perfect responses to a different problem. They were made for stone interiors, for vertical scale, for public storytelling, for devotion, memory, prestige, and awe. They turned architecture into atmosphere, and perhaps that is the most humbling part of all. The men who made them had no electricity, no modern chemistry textbook, no industrial float glass, no precision cutter, no digital mock-up, but they had process. They had repetition. They had workshop systems. They had materials knowledge. They had visual discipline. They had patience on a scale modern production rarely tolerates. Most of all, they understood something we often forget. Beauty is not the opposite of labor. In the medieval world, beauty was the visible residue of labor. That blue was wood burned to ash. That red was heat held at the edge of disaster. That painted face was a hand steady enough to risk ruining a priceless piece. That towering window was a network of trades: transport, fuel, drawing, cutting, firing, soldering, and lifting. And that means the true blueprint of medieval stained glass was not a secret recipe. It was a chain of human skill, organized so well that it could turn earth and fire into light. Even today, conservators and historians still learn from these windows because the old techniques endured with remarkably little fundamental change from the medieval descriptions onward. The methods were so effective that, in their essentials, they remained the foundation of stained glass making for centuries. So the next time you see a stained glass window, do not ask only what story it tells. Ask what forest fed it. Ask what furnace softened it. Ask what hand dared to cut it. Ask what painter knew exactly how much darkness to leave so that light could do the rest. And if you want more journeys into the hidden manufacture of the pre-industrial world, subscribe and stay with Before the Machine, because behind every ordinary object in history, there is an extraordinary process, and behind every beautiful result, there was always someone working in heat, dust, weight, and risk to make it real.